Hello, this is section 8.1 sequences. Introduction. So sequence is a function that computes order list. So every person in the United States uses about 100 gallons of water per day. And the function f of n equal to 100n generates the terms of the sequence as 100, 200, 300, 400, 500, 600, 700 when n equal to 1, 2, 3, 4, 5, 6, 7, and so on. And this order list represents the gallon of the water used by the average person after n days. So sequences. So we have infinite sequences is a function that the set natural number as a domain. And finite sequence is a function domain is d equal to n through the 1 through the n or some fixed natural numbers. That's very important. Okay, natural numbers. Alright, instead of the letting y represent the output, it is common to write the a sub n as f of n, where n is the natural number in the domain of the sequence in terms of sequence r. So, which means what? This is actually the domains. So, always the natural numbers, okay? And then first term is a sub 1 is same as f of 1. And then second term a sub 2 as f of 2 and so on. And nth term, the general term is we call the a sub n, which is same as f of n. So write the first four terms of the each sequence. So first four terms, which means first term is a sub 1. So we should use a n as a 1 to plug it in. And then just compute equal to 4. And second term, which is f of 2, that as n. So 3 times 2 plus 1 equal to 7. A sub 3, which is n is a 3 right now, so 3 times 3 plus 1, which is a 10. A sub 4, which is 4, which is 3 times 4 plus 1, equal to 13. So there's a 4, 7, 10, and 13. That's all. Alright, next go to the next page. Now we're going to find the first four terms too. Same thing. So a sub 1, same as f of 1. So 2 times 3 to the 1 plus 1's power. So 2 times 3 squared. So 9 times 2, which is 18. And a sub 2 means same as f of 2, which is 3 to the 2 plus 1 power. So 2 times 3 cubed, which is 2 times 27, which is a 54. A sub 3 is, n is a 3. So 2 times 2, 3 to the 3 plus 1. So 2 times 3 to the 4th power, which is 2 times 81, which is 162. Okay, so 4 means f of 4, which is 2 times 3, but 4 plus 1's power. So which is 3 to the 5th, which is 2 times 243, which is 486. Okay, so that's the first four terms. Now the third function, first term is -1, but there's a two place of n's. Oh no, three places, n, right? So we are using the n number to plug it in right there. So n is a 1 this time. So, okay, so which means, okay, let's put it this first. Okay, so same as f of 1. And -1 to the power 1 of 2 times 1 over 1 plus 2. Okay, which is simplified, so -1 times 2/3, which is a -2/3. Is same as f of 2, which is -1 squared now. 2 times 2 over 2 plus 2, which is a 1 times 4 over 4, which is a 1. A sub 3 is same as f of 3, so n is a third power. 3 times 3 over 3 plus 2. I got -1 times 6 over 5, which is -6 over 5. The last one, f of 4, which is -1 to the power 4. 2 times 4 over 4 plus 2. I got 1 over 8 over 1 times 8 over 6, which is the same as a 4/3. Okay, all right, that's all. Alright, recursive sequence. Some sequences not defined using a general term, which is a general term I'm using as a sub n. Okay, sometimes you can describe that. So instead of that, you define the recursively. So with the recursive sequence, we must find the a1 through a sub n minus 1 before we can find the a sub n. So the sequence is actually going to be a1, a2, a3. And then in the middle, they say a n minus 2, a n minus 1, and a sub n, there's n plus 1, and then a sub n plus 2, so on, okay? So which means, if you notice, okay, one less than an n term is the previous term of the a sub n, okay? So the question said write the first 4 terms again of the recursive sequence, okay? So a sub 1 is already given as a 1. Now, in order to find the second term, we're going to start to n equal to 2, which is a sub 2 is the same as 3 times a to the n minus 1, which is 2 minus 1 plus 2, okay? So which is 3 times is a1 plus 2, but a1 is now 1 plus 2, which makes a 5. So that's the second term. Now, in order to find the third term, we have to use n equal to 3. So n equal to a sub 3 is 3 times a to the 3 minus 1 plus 2, same as 3 times a squared plus a sub 2 plus 2. And then a sub 2 is a 5 plus 2, so it makes a 17. So one more. So answer 4, which is 3 times a sub 4 minus 1 plus 2, which is 3 times a sub 3 plus 2 plus 2, and 3 times a sub 3 is a 17 plus 2, so equal to 53. Okay, so first one is 1 and 5 and 17 and 53. That's so in order to find the next term, you have to use the previous terms. Okay, example 3. Suppose that the initial density of other female insect is 4,000 per acre and the R equal to 0.5. Then the density of the female insect during the year n described by f of 1 equal to 4,000. So that is the initial number. And then function goes with 0.5 times f of n minus 1. So if you want to rewrite this one as a sub n is 0.5 times of a sub n minus 1. Okay, so you just need to multiply 0.5. So actually it becomes decreasing. So first of all, we write the symbolic represent in terms of a sub n. So we can write it already. So a sub 1 is 400. So in order to the a sub n is 0.5 times of a sub n minus 1, which is n must be the greater one this time. Alright, finding the a sub 4 and interpret the result is the density of female insect increasing or decreasing. So actually it's decreasing because you multiply, actually get the less because I have, right? So a sub 1 must be 4,000. And then a sub 2 is going to be 0.5 multiplied by a sub 1. So 0.5 times 4,000. So half of 4,000 is 2,000. And then a sub 3 is 0.5. Now you have to use a sub 2 to multiply. So 0.5 times of 2,000, which makes 1,000. So a sub 4 is 0.5 times a sub 3. And 0.5 times 1,000, which is 500. So these are actually the decreasing, okay? General term and the sequence you can find the f of n equal to 4,000, 0.5 to the n minus 1 power. Use this representation to find the a sub 4. So f of n, which equal to 4,000 of 0.5 to the n minus 1 power. So same as a sub n is 4,000, 0.5 to the n minus 1 power, right? So now looking for 4, so 4,000, 0.5 to the 4 minus 1 power, which is a 3. 4,000, 0.5 cube, which come out as 500. So same thing. Yeah. You got the same answer, this one. Check it out. Okay. All right, example 4. Let a recursive sequence be defined as the following. So a sub 1 is a 16, and in following the sequences, you can find more than 1/2 of the previous term to multiply by. So find the first 4 terms and then the graph to these terms, okay? So a sub 1 is 16. Now a sub 2 means half of 2 minus 1 is a 1, which is half of 16 is going to be 8. And a sub 3 is a half of a square. So half of 8 is a 4. And the a sub 4 is half of a sub 3, which is a half of 4, which equal to 2. Okay, so you got 16, 8, 4, and 2 as sequences. So, and x equal to 1 is a 16. So about here. And the a sub 2 is 8. And the a sub 3 is a 4. So just decreasing by half, right? And then 2. Yeah. So this is it. This is how you plug it in. So it's not a curve or anything. You just have a dot graph, okay? All right. So this is just about the general sequences. Okay. So now I'm going to talk about the arithmetic sequences, okay? So suppose that a person, so starting salary is 30,000 per year, and thereafter this person received 1,000 raise every each year. The salary after n years of the experience is represented by 10,000 n plus 30,000, okay? Where f is a linear function after 10 years of the experience, the annual salary would be the f of 10, which is 1,000 times 10 plus 3,000, so about 40,000. So if a sequence can be defined by the linear function, and it is a arithmetic sequence. So infinite arithmetic sequence is a linear function f whose domain is a set of the natural number. The general term can be written as a sub n equal to dn plus c, which the d and c are the constant a sub n equal to f of n. So our arithmetic sequence can be defined recursively too. And then d is a constant term that can be increased or decreased. And then in order to find the common difference, you can just subtract the two next terms from the right from the left ones, okay? And this d we call the common difference. When d equal to 0 means sequence is a constant sequence. Finite arithmetic sequence is similar to the infinite arithmetic sequence, except the domain is d equal to 1, 2, 3, 4 to the n, where n is a fixed natural numbers. So arithmetic sequence is giving you the linear, which is like a slope, right? This is how much increasing from this one, okay? All right, so let's get that the problem. So example 5, determine if the function is arithmetic sequence, okay? So this is actually the f of n, same as 2n minus 2. So yeah, increasing by 2, right? Don't you see it's a slope? So if the sequence come out as a linear equation, so yeah, yes, it is arithmetic sequence, okay? But the B is actually the arithmetic sequence means you have to have a line. But when I'm connecting this point, looks like a curve to me, right? So this is not, no, it is not a arithmetic sequence, okay? It's like exponential, okay? And this one, let's see, x is increasing by 1. That means y must be increasing by constant number, okay? But this is actually the 3, this is actually 5, and this is actually the 7, and this is actually the 9. So that's not the same, isn't it? So nope, it is not. Okay, so this is not the arithmetic sequence. So arithmetic sequence means the number has to be increased by the constantly, okay? All right, so terms of the arithmetic sequence, okay, so this we call the general form. Or you can put this way too, okay? All right, so the first one you use the first term and d, and the second one is any term and d, okay? Oh, okay, this is k minus r, so I don't know why they put it this way. Okay, so all right, a sub n is a sub k plus, oh, hold on a second, what am I doing here? Okay, sorry about that. So let me think about this, okay? So in order to find this one, okay, there's something is wrong here. So a sub n is a sub k plus n minus k times d, okay? That's the right way. All right, so find the general term for each arithmetic sequence, okay? So when they have a first term given and these are given, of course, I'm using the first one, okay? So first one is a sub n is a sub 1 plus n minus 1 times d. So a sub n, which is a sub 1 is 4 and plus n minus 1 and times by 3. And then you can just simplify 4 and then you multiply by inside 3n minus 3. You can say 3n plus 1 is going to be the a sub n. But I like this one too. Now, this one doesn't have an a sub 1 and d this time, right? So I want to use the second equation. So a sub n is same as a sub k plus n minus k times d. So I want to label as n is always greater than k. So in here, I want to say n is so 4, n is a 7, and then the k is a 4. You see the sum numbers, okay? I'm using this number, okay? So a sub 7, a sub 4, n is a 7 minus 4 times d. We don't know about that, okay? But we only know the value of the a sub 7, which is a negative 4. A sub 4 is a 2 plus 3d. And subtract 2 both sides. 6 equal to 3d. Divided by 3. I got negative 2 equal to d. So I got d. Now, in order to find the a sub 1, right? Okay, so a sub 1 is, okay, so now I want to say n equal to, it doesn't matter, you can do this, okay? So n equal to 4, and then k equal to 1. So you use this form, right? So a sub 4 equal to a sub 1 plus 4 minus 1 and equal to times by d, which is a negative 2. But a sub 4 is the 2. A sub 1 plus 3 times negative 2. So 2 equal to a sub 1, which is negative 6. And then add 6 both sides. I got a equal to a sub 1. Alright, now we are ready to write this. A sub 1, a sub n is a sub 1, which is a plus n minus 1 times d, which is a negative 2. When you are distributed, I got 2n plus 2. So I got negative 2n plus 10, which is a sub n. Which means now you can find any term in that sequence. Okay, so example 7. Find the symbolic representation formula for the arithmetic sequence given by this, okay? So the sequence already start by this one, okay? So there's a number, 7, 6, 4.5, 3, 1.5, 0, and negative 1.5. But this is already the arithmetic sequence, so we need to have an a sub 1, which is a 6, and also d2. So how do you find the d? You just need to subtract from the 4.5 to 6. 3 minus 4.5, 1.5 minus 3, and 0 minus 1.5, and negative 1.5 minus 0. So either ways, you get the negative 1.5. So that's the d. Now we are ready to write it. So a sub n is a sub 1 plus n minus 1 times d. A sub 1 is a 6, n minus 1 times by negative 1.5. Which is a sub n. Now simplify 6 multiplied by the inside negative 1.5 n plus 1.5. Now your a sub n is going to be negative 1.5 n plus 7.5. Okay, so that's all. Now example A, determine if f is a geometry sequence. Okay, so geometry sequence means instead of the adding and subtracting for the common difference for the arithmetic sequence, this is being multiplied. So in this time, okay, so f of n, so let's kind of check it out to plug it in. Okay, 2 times 1 minus 1 to the first power, which is a 0. And then f of 2 is 2 times 2 minus 1 to the second power, which is a 2. And then f of 3 is 1 cubed equal to 2 times 8, which is 16, okay? So the German is something multiplied, but the problem is a 0. Any number you multiply by 0, you won't get 2 at all, okay? So it's not a geometry. Now the second one, actually this is a curve, right? So which means, yeah, there's a good candidate to be the a geometry sequence, okay? So this is actually, if you kind of see it, so first order pair is the 1 1, like a 2 2, about 3 and 4, 4 and 8, and this is about 5 and 16, okay? So now you can see it's multiply by 2, multiply by 2, multiply by 2, get 8, multiply, yeah. So it's everything is multiplied by 2, right? So yes, it is a geometry. Okay, what about C? Okay, so here, same thing too. When you check that it's increasing by 1 as x, but y is also increasing or decreasing by adding or subtracting or multiplying, but this is not actually adding it, right? So this is actually the multiply by 1/3 or divide by 1/3, right? Divide by 3, right? So multiply by 1/3 to get 1/3 again. So same number has been multiplied. So yes, it is a geometry sequence. Okay, so geometry sequence means suppose that a person with the starting salary of the 30,000 per year, and then received a 5% raise instead of the 1,000 raise each year. So if the a sub n is f of n, compute the salary at the beginning of the nth year, then f of 1 equal to 3,000, and the second year you got 3,000, and the increasing 3,000 to the 5%. So you have to use a 1.05, and then third year you gotta this one to plug it in to multiply by again, and then you that's the amount so you're getting each year. So previously you gotta multiply by the 1.05, okay? So the general term is 3,000, 1.5, n minus 1 power. Okay, so f of 10 is you plug it in and it's 10 to get that amount. So you can get any amount you can. So geometry sequences are capable for either rapid growth or decay, and the terms of the geometry sequence can be found by multiplying the previous term by r. So r we call the common ratio. An example, we can represent it as a population, salary, automobile, depreciation, okay? When they use a percentage, we can use a geometry. Okay, so infinite geometry sequence. Infinite geometry sequence is a function defined by f of n equal to c times r to the n minus 1, where c and r are non-zero constant. The domain of f is a set of the natural numbers. So geometry sequence can be defined recursively by a sub n equal to r times a sub n minus 1. Okay, so first term is a sub 1, which is a c, and the r is going to be you divide by the next two terms in each other. Okay, then we call the r as a common ratio. So it always come with the curves. Okay, so like exponential forms. So find the general terms of each geometry sequence we have here. So which is the formula was a sub n is c times r to the n minus 1. So general term is a sub 1, which is 3, and the r is 5 over 2 to the n minus 1 power. So that's all. And then another way you can find from the b is, okay, there's another forms you can use. A sub n is always a sub k to the r to the n minus k2. So you can use this one. So this time is n equal to, n is always bigger than k, so 6, and k is 3. So a sub 6 is a sub 3 of r 1/4 to the n minus 1 6 minus 3. But a sub 6 has a 1/4, a sub 3 has a 2 of 1/4 the q. Okay, well, oh no, we are looking for r, right? We don't know. Oh yeah, sorry. What am I doing here? Sorry about that. So, which is a sub 3 r to the the 6 minus 3. But a sub 3 is actually the 2. The r is going to be a q, right? So divide by 2, which is the same as multiply by half. So 1/8 equal to r cubed. And then cube root both sides, r equal to 1/2. Okay. So and then to find the a sub 1, so same thing too. So a sub, this time is a sub 3, right? n is a 3 this time, okay? And then a sub 1, and then r to the 3 minus 1 this time, okay? So a sub 3 is a 2. A sub 1 we're looking for r is a 1/2 to the square. So 2 equal to a sub 1, which is a 1/4. And multiply 4 both sides. 8 equal to a sub 1. So which means a sub n is now a sub 1, 8. And then 1/2 to the n minus 1. So this is general term for the problem B. All right. Thank you for listening.